Okay, let's get started on lesson 62, since we didn't get to it last week. This is a rather beefy lesson, so it should be a little bit of a review, but it has some twists and turns in it. So everyone pay attention, make sure you're not doing other things while you're watching this video. Let's talk about square roots. You've been doing square roots probably since you were in about 5th grade, maybe even younger, so I'm not expecting this to be too difficult. Like if I said, what's the square root of 4? Everyone should know that the answer is 2. Square root is just simply what times itself gives you the number under the radical. This symbol right here is called a radical. And there's usually an index on your radical. If it's a square root, you don't write the index, it's assumed. But it would be a 2 for square root. But we don't write that. We're going to be doing in this lesson cube root and fourth roots. So this one is the square root of 16, so you'd say what times itself gives you 16, and that would be 4. There's also positive and negative square roots. Like if we had negative 2 times negative 2, it would also give us 4. And negative 16 times negative 16, negative 4 times negative 4 will also give you 16. But we're going to be dealing with the positive roots unless it says otherwise. Okay, having a little trouble with my writing gadget here. Okay, another thing you need to know with square roots is if you take a square root times itself, so what would happen? You can multiply what's underneath the radicals, but we'll get to that a little bit later. Anytime you take a square root times itself, you just get the number that's under the radical. So if I took the square root of 2 times the square root of 2, we're going to get to this later, but you would get the square root of 4. You can multiply what's under the radical, and the square root of 4 is 2. So just keep in mind when you take a square root times itself, it frees the number. Same thing, if I have the square root of a times the square root of a, that would just be a. A radical times itself just gives you what's under the radical. So the square root of x minus 1 times the square root of x minus 1 would just be x minus 1. And this is just written in a different form. This is the square root of 2.37 squared. So that would be the square root of 2.37 times the square root of 2.37. So you would just get 2.37. If the index, that's that little number I was talking about, if the index matches the exponent, you free what's underneath the radical. Okay, a little bit of calculator work here. Use a calculator to determine to 5 decimal places the square root of 18. So all you have to do is get out your calculator. I'm going to find mine and get it out here for us. Calculator. Here's my calculator. Use a calculator to determine to 5 decimal places the square root of 18. So you just put in your calculator and then push the square root button, and we're going to get this long number. This is an irrational number. It doesn't end. It goes on and on and on forever. So they just want you to round it to 5 decimal places. So I would count 1, 2, 3, 4, 5, and then I would look at the 6th number to see if we need to keep this the same or round it up. Since it's a 0, less than 5, we're going to keep it the same. So our answer, of course I can't memorize that, and it'll go away as soon as I start writing, is 4.2426. And remember, I looked at the 6th number and it was a 0, so I'm not going to round it. So that's all you have to do on these. So it's just strictly using your calculator. Okay, this one says use a calculator to determine the 2 square roots. So if it says 2 square roots, we're going to have 2 answers. We're going to have a positive and a negative one. Like if I had the square root of 4, I told you before there's 2 answers. You could either get 2 squared gives you 4, or negative 2 squared gives you 4. Usually we're just going to get the positive square roots unless they say so for right now. So they want us to use our calculator to determine the 2 square roots of 10. So we get our calculator back out. This time I'm going to put 10 square roots, and there's the number. They want it to 6 decimal places this time, so you have to pay attention to what they want. So we count 1, 2, 3, 4, 5, 6, and you're going to look at the 7th number to see whether you round the 7 up or down or keep it the same. So since it's a 5 or above, I'm going to round this number up to an 8. So let me just write that number in. It's going to be right here 3.162278. So these should be really easy. Okay, example 3 is without a calculator, write the squares of the counting numbers 1 through 20. I'm not going to do all these, but without a calculator. So when it says write the squares, is you're going to take the number times itself. So 1 times 1, 2 times 2 would be 4, 3 times 3 is 9, 4 times 4 is 16. You get the picture? 25, 36, 49. Now these numbers that I'm writing are called perfect squares, and you need to kind of memorize them. I mean, they should be familiar to you, and you can always come up with a list of them at any time you want, but they should be really familiar. Like if I say the square root of 81, you should just say 9. 100 squared would 10 squared is 100. 11 squared is 121. 12 is 144. I guess I'm doing all these. 169. Here's where they get a little bit tricky. 14 is 196. The more you know, just the easier problems will be later. 225. We usually don't go this high. You won't see these very often. 256. 17 times 17 is 289. 18 times 18, 324. 19 times 19, 361. And of course 20 times 20 is 400. So you kind of need those in your head to be able to do the next problem. It says without a calculator, determine what two consecutive integers the square root of 10 lies. So the square root of 10 is in between. We find our two perfect squares. So the square root of 10 would be somewhere between the square root of 9 and the square root of 16. So you find the two perfect squares that this one is in between. So the square root of 9, that's way up here, and 16, 10 is in between those two perfect squares. So you want to find the integer it lies between. Well, the square root of 9 is 3, the square root of 16 is 4. So the square root of 10 lies somewhere between 3 and 4, and it's going to be closer to 3 because 10 is closer to 9. I'm not sure if I explained that one well enough, so let me think of another one. Determine between what two consecutive integers the square root of 12 lies. So we want to find the perfect square that 12 is. That's going to be the same one. That was a bad example. Let's think of the square root of 38. So what's the perfect square right below 38? Well, that would be the square root of 36. So that would be 6 times 6. The next one would be 7 times 7 would be 49. So these are the two perfect squares. And we have those right here, 36 and 49. So the square root of 36 is 6. Square root of 49 is 7. So 38 lies somewhere between, square root of 38 lies somewhere between 6 and 7, and it's going to be closer to 6. Okay, moving on. Now we've done square roots. Now we're going to move on to cube roots and fourth roots. So all cube root is, do you see the little 3? That's called, remember I said before, this is called our index. With square root, we don't write it because it's so common. But with a cube root, we want to say what times itself 3 times will give us the number under the radical. So you can just start guessing numbers. 1 times 1 times 1. We know that doesn't work. 2 times 2 times 2. Well, 2 times 2 is 4 times 2 is 8. So the answer would be 2. 2 times itself 3 times gives us the number under the radical. So that's our answer. Here's another one. If the index is odd, you can have negative numbers under the radical. If it's even, you cannot have negative numbers under the radical. So you can just start numbers like 3 times 3 is 9 times 3 is 27. That didn't work. 4 times 4 times 4 doesn't work. So if we did have 5 times 5, negative 5 actually, times negative 5 times negative 5 does give us negative 125. So the cube root of negative 125 is negative 5. Now remember how I said if you square a square root, the number comes out? The same thing, if you cube a cube root, the number under the radical comes out. So that would just be x. So, for instance, if we had the cube root of 2 cubed, the answer would just be 2. If the index matches the power, the number comes out. And we'll get more into that when in Algebra 2, why that works. But for right now, you need to remember the index matches the power, the number comes out. So let's look at a couple of these. Almost done. Cube root of 8. So we're saying what times what times what? What times itself 3 times gives us 8. Well, I think we did this one right up here, didn't we? Yep. So we get 2. Here's one. This one's a little bit tricky. This is the 4th power, 4th root of 81. So we'd say what times itself 4 times will give me 81. So you can just try 2, see if this works. 2 times 2 times 2 times 2. So that would be 4 times 4 is 16. That doesn't work. Let's try another one. 3 times 3 is 9, times 3 is 27, times 3 is 81. So the 4th root of 81 is equal to 3. And one more. The cube root of negative 27. So we know it's not 2 because we did that here. Let's try negative 3. Negative 3 times negative 3 times, that would be 9 times negative 3 works. And so that would equal negative 3. I'm hoping this is somewhat of a review. Okay, if you have an equation, this is a quadratic equation. If you have an equation, there's 2 answers to these. And we're going to get into this more later. What squared is going to give you 4? Our first thought would be 2 squared gives us 4. So we would say x equals 2. You need to be careful here because there's 2 answers that will make this true. We can also say x equals negative 2. So you want to watch this, and we'll get into solving quadratic equations later. So if you ever see an equation like this and you just start filling in your numbers, just remember that there's, with the 2, with the quadratic equation, there's usually 2 solutions. This is something, a notation that you might not have seen before. This is 7 plus or minus 2. What that means is you're going to have 2 different answers. You're going to have 7 plus 2, and that will give you 5. And we would have 7 minus, oops, that would have been 9. It's late, I'm doing this at 11:35 at night. 7 minus 2 gives you 5. So when you have plus or minus, it means you're going to do 7, you're going to do the number plus the second number, the number minus the second number. So this is just all preparation for future work with radicals. So let's do this last problem. Evaluate. This isn't much different than what you had before, except we have this plus or minus right there. So we get negative 2 squared. There's no parentheses around the negative 2, so it's just, we leave the negative and we just square the 2. So it's negative 4. This is negative 3. This time there is a parenthesis squared, so it would be negative 3 times negative 3 would be 9. And we have plus or minus the square root of 4 is 2. So we get negative 4 plus 9 will be 5 plus or minus 2. And here we go. This is similar to what you did up there. So you would get 5 plus 2 equals something. 5 minus 2 equals something. So you get 7 and 3 are your 2 answers. And you can just write it as a 7, comma 3. So that's it for lesson 62. I want you to use the help board if you haven't used it this week. I'm going to check it because I know last week the lessons were kind of difficult, so I want to make sure I answer any questions before class. So that's it for lesson 53. 62. I don't know where I got 53. Sorry.